apologize. I don't have a ton of time here, but I'll do the best that I can in the short period of time I have to make this. All right. So what we want to do is we want to start with our just sketch. So we have a elevated surface, 10 meter, and we're going to throw this object up at 15. It's a vector. Goes up, slows down pretty quickly, comes to a stop. 0 at the apex, follows the same flight path, and then accelerates, eventually hitting the ground below, which we're going to make 0. We'll put 0 at the ground, put in our coordinate system or directional or SWARO here, so this would be 0 and this would be 10. At the apex, we have a velocity of 0 meters per second. You don't want to forget that. And then gravity is the thing that's making this constant, so it's negative 9.8 as it's against the SWARO. So we can answer these two things right away. 0 meters per second and negative 9.8 meters per second squared. So then we have to produce our graphs. So we know what the graphs look like. They don't really change. Come up and then back down. Remember that we also have this negative time that has physical significance. That's all we need to find on that graph. The other graph, the velocity time graph, looks something like this. And this is our initial speed. So how do we get these things on our calculator? You probably already have some stuff in your calculator like I do here. Just need to change some of these things. Like, for example, we want to change the initial velocity to 15, and we change our initial height to 10. Then the same thing over here, we change our initial velocity to 15. Looks like I lost my x. So we'll insert an x. Turn this one off first. We're going to graph that. So we got a parabola, but we can't see it all, so we have to change our windows. So our windows off a little bit. We make our y max higher. Put the y max at maybe 25. See what that looks like. Now you can see the peak. So we'll go through and find all our important points like the max. So the max is 21.5 at 1.53 seconds. Then we also have our times, so we'll calculate the zeros now. We'll go through here and get over to the positive root. Went too far, right there. And there, and we get 3.6 for this time. And then I also have to come back over to the other side and calculate the other 0. We go below the x-axis, above the x-axis, and we get negative 0.56. So now we have our two roots. We have our max and the time when the max occurred, and that's really all we need to be able to do this. So first question is, how fast is it going when it hits the ground? So hit the ground at 3.6. So now we're going to use our other graph to kind of figure out how fast it's going with the value function. So we go back to our y equals. We'll go ahead and turn this graph off now and turn on our velocity graph. So initial velocity was 15, and this is number 1, by the way, equation number 1 on our magic physics formula sheet. So we graph this, and we want to once again go to calc, and this time we want to use number 1, which is value. Put in our time, where it hit the ground, 3.6, and I get negative 20.28 for the speed it lands at. Now if you use a more exact time than 3.6, you're going to get a little bit better answer, but that's pretty good. How high did it go? That's our peak. We found that to be 21.5 meters. How long did it take? It took 3.6 seconds to get to the ground. Alright, we get that right from our graph. How long does it take to get back to the pro's hand? So on the way up, it took 1.53 seconds to the apex. To get back to the hand would take an additional 1.53. So we're looking at 3:06 as the total time here. How long would it take for the physics pro to launch the object from the ground, go to the same height as before, and then land with a speed of negative 20.28? So remember, his V naught would be 20.28, and we would go to a max height of 21.5. All that's included in that problem. So the easiest way to do it is take our graph and just shift the parabola. So really what we're doing is we're taking our negative root, which is this right here, negative 0.56. We're going to take the absolute value, 0.56, and then add that to 3.6. So we're going to take 0.56 plus 3.6, and we get 4.16. That's how long it would take to throw it from the ground with a speed of 20.28 up to the apex and then back to the ground, landing with negative 20.28. So that's how you can get these pretty easy. You know, like I said, that would get you a 20 out of 25, which isn't too bad. Now you'd have to go through and use your magic physics formulas, and to be honest, I just don't have time to get into that now. So do the best you can, and good luck on your quiz, and I'll see you when I get back.